Hi, welcome to the 2014 Math 7 SOL test. We're on question number 18, and it's asking us to determine which of these answers is a false answer. We're going to start with answer A, saying all squares are rectangles. So what it's saying is every square that exists must fall into the rectangle family in order for this to be true. So let's talk about the rectangles family for a second. So rectangles, and sorry for my drawing, rectangles are quadrilaterals that have four right angles. Well, I think something we know about squares, all squares have four right angles. Well, there's a little bit more to our rectangle rule than that. All rectangles have opposite sides being the same length. So this side and this side are the same length, and this side and this side are the same length. Well, you know what? We know that in squares too. This side and this side, and this side and this side, in fact, all the sides are the same length. So far, every property of the rectangle falls, or every property of the rectangle is also checked off by the square. One other property of a rectangle, in order for it to be a rectangle, is that the diagonals, the measurement from one diagonal vertex to the other, this measurement right here, they literally bisect one another. They cut each other in half. And you know what? The diagonals in a square bisect each other as well. One last thing about these bisects we know, these diagonals we know in a rectangle, is these diagonals are equal to one another. So the measurement from here to here is equal to the measurement from here to here. And that is also true in a square. The measurement from here to here is equal to the measurement from here to here. So all of these characteristics that we know about a rectangle are true in a square. So the statement, all squares are rectangles, that is a true statement. So this one's true. Now we're not looking for the true one, we're looking for the false one, so we can cross that one off our list. All right, how about the next one? All squares are parallelograms. Well, since squares, by definition, are parallelograms with four right angles and four congruent sides, then this is a true statement as well. That's the definition of squares. The definition of a square is that it is a parallelogram with four right angles and four congruent sides. So we can cross that one off our list as well. All right, how about this next one? All rhombuses are squares. So that means every rhombus has to fall into the square family. It has to have all the characteristics of a square. So let's go ahead and draw another square again and talk about the characteristics of a square. A square, first of all, has four right angles. And when we think about a rhombus, you know what? Rhombi, or a rhombus, does not necessarily have right angles. It has opposite angles being equal to one another, but that does not mean that they are right angles. So this tells us, that little piece of information right there, rhombi, or rhombuses, do not all fit into the square family. The only rhombuses that fit into the square family are the rhombuses that have right angles, but they don't have to have right angles. So to me, we're looking like answer C is the best answer. But let's finish up and look at answer D real quick. It says all rhombuses are parallelograms. Well, that's part of the definition of a rhombus. Rhombuses are parallelograms with four congruent sides. That's the definition of a rhombus. Rhombuses are parallelograms with four congruent sides. So since it's literally in the definition of a rhombus, this is a true statement as well. So we're going to cross that off our list again since we're looking for false statements. All right, so the key to this question, everybody, is making sure you understand all the different properties or characteristics of these different kinds of quadrilaterals. Make sure you know all the characteristics of rectangles, squares, rhombuses, and parallelograms. Be ready for a question like this when you get to your test. All right, everybody, thanks for watching. Have a great day.